All right, pre-algebra folks, this should be a brief video about histograms. So we're going to take you from frequency table to completed graph. All right, and I love this kind of sweet looking rainbow histogram. How cool is that? Just pretend. I think it's cool because it's a rainbow. It's even Roy-G Biv if you look. Red, orange, yellow, green. Remember that from science? Anyway, sick histogram, bro. Let's learn more about them. All right, a histogram uses bars to display numerical data that have been organized into equal intervals, okay? So when we say numerical data, we're talking about more than one number, which is why the grammar here. So the data have been, or you could say the data has been. You can actually say both on that because you can use data as one term meaning singular, like the data, so it's the data that we have, or these data. You can use it as a plural too. Kind of cool. Anyway, it's not a bar graph. It's not the same thing as a bar graph. We discussed this in class. A bar graph shows discrete bars. Okay, so this could be favorite animal. So folks like me, meow. Or you know, if your favorite animal is a cockroach, I'm sure there's somebody. Okay, or maybe your favorite animal is the actual human being. I don't know, I'm just making stuff up here, but it's not a bar graph. That's not what a histogram is. A histogram shows intervals, and it shows those intervals touching because you're showing something that's continuous. How to make a histogram. 1. Organize your data into evenly spaced intervals. Evenly spaced intervals. Draw a graph with an x-axis and a y-axis labeled appropriately. Your x-axis is broken into the chosen... Why? I did not mean to do that. Let's fix that. Sorry. Your x-axis is broken into the chosen intervals from beginning to end. The y-axis shows the number for each interval, starting with 0 at the bottom and going up as high as needed. Finally, fill in each interval with a bar showing the number in that range. So let's take a look at this example. So these are the ages of people entering a store. Now, I like how this is already set up for us. It's already set up with our intervals. So that's one thing you're going to have to do. Say you were collecting the data, is you have to decide what your intervals are. Okay? And in a graph like this, the actual numbers on the graph don't really matter. We see there's 5 tick marks in the interval 1 to 10. That could be 5 1s. It could be 5 10s. It could be a 1, a 2, a 4, a 6, an 8, and a 10. I mean, it could be any of those. Okay? Actually, it couldn't be all of those because that would be 6 instead of 5. Did anybody catch that? I listed too many. But anyway, it doesn't matter what the actual numbers are. It just matters that they're in that interval. Once we have our intervals, so you have your tally marks. So this would be actually collecting the data. And then you can consolidate with your tally marks. And now you'll actually draw your graph. So you have an x-axis and a y-axis. And for this, my x-axis would be broken up into 1 through 10, 11 to 20, etc., etc., etc. And then my y-axis would have to go up as high as 20, but would basically have to start down at 0, or even if I wanted to, I could do that little thing, you know, where we saw that in class, where we have one of these, where it shows there's numbers there, but we're not using them for the 1 through 4. But it will probably just start at 0. And I'm not going to actually make this one because it's made for us. Let's take a look at it. So I got to move our friend here out of the way. Hold on. Let's take a look at this. Okay. So let's send this guy to the back. Send it to the back. Send backwards, please. Thank you. Okay. So here we have our histogram. So from 1 to 10, 11 to 20, and so on. We've got our little intervals. So you make little marks down on the x-axis showing our intervals. Label it, because that's age by year. And then frequency, so number of those actual people. Okay? So they ended up going by 2s up through 22, just so that you could fit everything, and so that your highest bar doesn't actually touch the top of your graph. Notice a title. Okay? Notice the lack of space between the bars. We're not going to have any space between the bars. Because the intervals are equal, all the bars have the same width. That's also important. We're showing that they are the same width because the intervals are equal, and you will not make one of these with unequal intervals. And then it was just a question of going over here to our tally marks and saying, all right, so that means I have 5 people with an age from 1 to 10. So we fill this in up to 5 for the bar. And then 8 up to, from 11 to 20, you have 8 people, and so on and so on and so on. So you are going to make one of these yourself in class. Now let's look at what happens when we have to interpret a histogram. Okay, so here's a histogram we have. They're test scores. And you have intervals from 60 to 69 all the way up to 100 to 109. So it looks like we got some kids got bonus questions in there. So notice first here, you've got your little squiggles, your little compacting mark, because we don't have any scores between 0 and 60. So that's pretty good. At least nobody got less than a 60 on whatever this test is. You got your scores, and then you got your frequency going up, in this case, to 16, counting by 2s. So the first question on here is, how many kids scored at least a 90 on the test? So find 90. Okay, at least a 90 would be from this mark that I just made and up. So I need to know how many are in this category and this category, and then I need to add them together. Well, in this first category, if we follow it across, halfway between 8 and 10 is 9. And then in this second category, the kids that got bonus questions here, they're right at 2. So that's 11. 11 kids scored a 90 or better. At least a 90. Okay, notice at least a 90 means 90 or better. What percent of kids? What percent this time? So now we're going back to what we know about percents. What percent of kids scored 79 points or lower? Well, I'm gonna change colors for you so you can see the distinction between the work for the two problems. We want 79 or lower. And we're looking for a percent here. So we're actually going to need the total over the number of kids that scored 79 or lower. So less than or equal to a 79. Well, we need the total. Let's find the total first. That means I'm going to have to add up the number in each category. All right, let's do that. We've got 4 plus 7, as you can see here, halfway between 6 and 8. Sorry, music came up a little loud there. Next category is 14. Next one we actually already found was 9 and then 2. So the total number of people or of test scores on here is 4 and 7, that's 11. 11 and 14, that's 25. 25 and 9 is 34. 35, 36. Woo, big class. Or maybe it's more than one class put together. Making sure just to double check my numbers, 4 and 7, 11. 11 and 14 is 25. Plus 9 plus 2, 36. Good, just double checking. So we have the total number of kids was 36. How many of them scored a 79 or lower? Well, that would be just these first two categories, which would be the 4 and the 7, so 79 or lower, so 11 kids. And that right there gives us the fraction of kids that scored 79 points or lower. And in order to change that to a percent, we didn't have any trouble doing this the other day with an example in class. We're going to divide 11 divided by 36 times 100, 30.6%, about 30.6%. Next question, is it possible to tell the highest test score? Well, it is not. It is not. Just because we know this interval up here at the top is 100 to 109, we cannot tell how many scored way up here at 108 or 109. We don't even know if anybody scored 109. We just know 2 kids scored in this interval. So no, I cannot from my graph tell the highest test score. In what range is a student most likely to score on the test? Well, that should be really easy. Look at your histogram. Which one is the one that has the most in it? It would be our 80 to 89 category. 80 to 89 category because it is the tallest. So between an 80 and an 89%. That would be the most likely category, most likely interval for a kid to score, because that's where most of the scores were. So most of the scores were B's. All right, and that takes care of a nice brief histogram video. You should be good to watch this tonight, and then hopefully it'll be nice out tomorrow, and we can take a little trip and create our own histogram, collect some of our own data. All right, guys, see you in class.